Hey, welcome back to Info 3370, studying social inequality with data science. We're about to talk about left join. So why would we use left join? This function is useful when we have two data sets and we want to combine them. And there's some key that tell us which rows in the first data set correspond to rows in the second data set. So let's make that more concrete. In a previous exercise, we created the pivoted data frame. And this data frame has rows that correspond to some summary of an income distribution. So among college-educated workers observed in 1962, the 10th percentile of incomes was $3,720. Here we have this summary for those who went to college and those who did not, across many years for three summary statistics, the 10th, 50th, and 90th percentiles. And if you look up here, we have data on 1962, and if we look at the end of the data frame, we see we have data from 2021 and 2022. And so when you think about this, you'll realize that these dollars are hard to compare, because $1 in 1962 is not worth the same amount as $1 in 2022 due to inflation. So in order to address inflation, I used the Consumer Price Index to create this inflation.csv file. So we'll go ahead and load that file and see what's in there. So in this inflation file, we have two columns. We have a year variable and an inflation factor variable. And I created this so that if you take an income, take a dollar value in 1947 and multiply it by the inflation factor, you'll get to the equivalent value in 2022 dollars. So if we look at the bottom of the inflation data frame, we see that in 2022, if you take a dollar, you multiply it by 1 and get that same value in 2022 dollars. So this is great. Here we have this data set, and it has years and an inflation factor, and we have the pivoted data frame, which also contains years. So we want to do something to take the inflation value for the year 1962 and stick that over here in a new column on this data frame. And you can see this is tricky because we can't just append a new column, because here we have data like from 1947, and 1947 doesn't even appear in the data frame over here. So what are we going to do? This is where left join is helpful. So I'm going to create a new object, joined, and that object is going to start out with our pivoted data frame that I'm going to pass into a call to left join. So left join takes two arguments at the beginning, two data frames that are going to be combined. So the first data frame X, it's going to pull from the pipe up above. So pivoted is the first data frame. The second data frame we're going to merge with is inflation. Then a key argument in left join is the by argument. So this tells it which variable exists in both data frames and tells us which rows of the one data frame correspond to rows of the other data frame. So in this case, that's going to be the year variable. So if we go ahead and do this and then look at our joined object, we now see that we have a new column here, the inflation factor, where it picked the 1962 value from the inflation data frame and added it to the 1962 row. So we see for all the 1962 rows, it's one value. For 1964, it's another value, and so on. And the reason we've done this is so that we can now mutate and create a new variable like income real dollars, which equals income times inflation factor. So if I look at that, we see that in 1962, the 10th percentile of incomes was $3,720. But put in 2022 terms, that's like the same as $35,981. So here adjusting for inflation was super important. So just to review, what we did here was we started with two data frames. We started with pivoted and we started with inflation. And what these two data frames shared was this key variable year. And we wanted to append the two together so that we pulled a new value from the inflation data frame that matched the year of a given row in the pivoted data frame. And the way we did that was with left join, where we told it we want to join by year. Now there are many kinds of joins. There's left join, right join, inner join, full join. And to illustrate those, I want to pop over here to the data wrangling cheat sheet from RStudio. So if we pull down here to the second page, we have a little section on joins. And in this hypothetical example, they have two data sets where they share this variable x1. And in data set A, x1 has the values a, b, c. In data set 2, x1 has the values a, b, d. And when we look at left join, what we just did, that says we're going to take data set A and keep all the rows that exist in data set A and append the values for x3 based on the matching values of x1. So in this case, A and B appear in both. They get these true falses, but C doesn't appear in data set B. So when we left join, the x3 variable will just be NA when we left join. Now if we right join, it's the same thing, except that it says it's going to keep all the rows of the B data set. So here, because A, B, D appear in the B data set, we have A, B, D, and we don't have C, because it appeared only in the A data set. Inner join keeps only the rows that appear in both data sets, so here that's only A, B, because they appear in both of them. And full join keeps all the rows regardless of whether they appear in A or whether they appear in B. And there are even more complicated joins that are filtering joins. So why do I focus so much on left join? I focus on left join because in our applications, often it's the case that we spend a while preparing a data set. And we're really careful in that data set about figuring out who the observations are that we want to speak to some population summary. And then we want to append a new variable into that data set, but we don't want to change which observations we've selected in that whole process leading up to this. Remember how we filtered and we pivoted and did a lot of work to get our observations straight. And so for this reason, left join is the function that I almost always use when I'm adding new columns to my data set. But you may use this in many settings, and you might find some really good situations for using left join, right join, inner join, full join. In any case, joins are really helpful because often we have information in two data frames and we want to bring that information together.